Welcome to this quiet space, a place for gentle stories and soothing contemplation designed to accompany you into a peaceful rest. Tonight, and for the nights to come, we will embark on a long and wondrous journey together. A journey into the heart of a mystery that surrounds us every moment of our lives. We will be exploring the history of the future, a contemplation on the silent, unending flow of time. I would be so very grateful if you would support this channel with a simple like and subscribe, so that these stories may find others who seek a calm harbor in the dark. And if you feel moved to do so, please leave a comment below to share where you might be listening from in the world tonight. It is a lovely thought to know we are all under the same starlit canopy, listening together. Now, find a comfortable position. Let your body feel heavy and supported, and let your mind begin to drift with the sound of my voice. And so our journey begins not in the distant cosmos, nor in the depths of the ancient past, but right here, in the soft and quiet sanctuary of this present moment. Just for a breath, let us rest here together, in the immediate reality of your own awareness. Feel the gentle weight of the blankets upon you, the subtle pressure of the pillow beneath your head, and the almost imperceptible coolness of the air as it enters your lungs, and the gentle warmth as it leaves. This is the only moment that has ever truly felt real, this luminous, fleeting island we call the present. All of your memories, all of your experiences, reside in a land called the past, a place we can visit in our minds but never touch with our hands. And all of your hopes, your dreams, and your worries, they live in a yet-to-be-discovered country, a horizon we call the future, a place that is always approaching but never arrives. We live our entire lives on the edge of this ever-moving present, a single, continuous point of light traveling along a seemingly infinite line. This is the most fundamental story we tell ourselves about time, that it is a river, flowing steadily and surely from a source we cannot recall to a mouth we cannot see, carrying us along in its current. We are born, we live, and we age, always moving in one direction, from the morning of youth to the evening of our years. A dropped glass shatters on the floor, but we never see the scattered shards leap back together to reform the glass. An egg is scrambled for breakfast, but we never see it unshamble itself back into a perfect, smooth ovoid of yolk and white. The river flows only downstream. But have you ever paused, in the stillness of the night, to wonder why? Why is this so? Why does the great river of time possess such a resolute and unyielding direction? The fundamental laws of physics, the very rules that govern the dance of atoms and the waltz of galaxies, seem to be surprisingly ambivalent about the direction of time. If you were to watch a video of two billiard balls colliding, and then watch that same video in reverse, both events would look perfectly plausible. The laws of motion and gravity work just as well backward as they do forward. A planet orbiting a star would trace the exact same elliptical path if time were to flow in reverse. At the most microscopic level, the universe does not seem to have a preference. And yet, our reality, the world we see and feel, is governed by an undeniable and irreversible arrow, a one-way street from past to future. The mystery of this arrow, the source of this ceaseless forward momentum, is one of the deepest and most beautiful questions in all of science, and its answer begins not with clocks or calendars, but with a concept that smells of old books and autumn leaves, a concept called entropy. The formal name for this principle is the second law of thermodynamics, a rather unassuming title for a law that dictates the fate of the entire universe. In its essence, the law states that, in a closed system, like our universe, things tend to move from a state of order to a state of disorder. This idea of disorder, or entropy, is the secret engine driving time's river forward. Imagine your bedroom, freshly cleaned and organized. Every book is on its shelf. Every piece of clothing is folded in its drawer. This is a state of high order, or low entropy. Now, as the days and weeks go by, without any effort to maintain it, what happens? A book is left on the nightstand. A shirt is draped over a chair. Dust settles on the windowsill. The room naturally, and without any malice, drifts towards a state of greater disorganization. This is a state of higher entropy. There are vastly more ways for a room to be messy than for it to be perfectly tidy. And so, just by random chance, it is overwhelmingly more likely to end up in one of the countless disordered states than in the one specific ordered state. This is not a force pushing things around. It is simply a matter of probability, and this simple truth applies to everything. A hot cup of tea is an ordered state. All the fast-moving energetic molecules are concentrated in the cup. As it sits on your table, it cools down. It doesn't do this because of a specific cooling force. It does so because the energetic molecules in the tea collide with the slower molecules of the surrounding air, sharing their energy. The heat spreads out, the energy disperses, and the system of the tea in the room becomes more disordered, reaching a state of higher entropy. We will never see the random motions of the air molecules conspire to spontaneously heat the tea back up, just as we will never see the scattered shards of a glass spontaneously reassemble. There is only one way for the glass to be whole, but there are near infinite ways for it to be broken. And so, time flows in the direction of the breaking, of the cooling, of the spreading out. The past is the place where the glass was whole, where the tea was hot, where the room was tidy. The future is the place where entropy is higher. The constant, silent, and universal increase of entropy is the arrow of time. It is the current of the river, pushing ever forward into an ocean of greater and greater possibility, of greater and greater disorder. This flow is not a feature of our consciousness or a trick of our minds. It is woven into the very fabric of reality, a deep and fundamental truth about the unfolding of existence. Every tick of the clock, every beat of your heart, every sunrise and every sunset is a small step along this grand journey from order to disorder. The memory of yesterday is a record of a lower entropy state, and the anticipation of tomorrow is an expectation of a higher entropy one. The river does not flow because we perceive it to. We perceive it to flow because it is the fundamental nature of the cosmos to unfold in this way, one probable moment at a time. And as we drift here, on the soft currents of this moment, we are part of that unfolding, a small, intricate, and beautiful eddy in the vast and silent stream that flows always and forever towards the sea. And so, we find ourselves drifting on this vast and silent stream, carried by the inexorable current of entropy toward an ocean of ever greater possibility. Each moment that passes is like a single drop of water joining the flow, an event that happens and then is gone, leaving only the memory of its passing. This one-way journey is defined by what we call irreversible processes, the quiet, everyday occurrences that, like the cooling of tea or the shattering of a glass, can never truly be undone. There is no more gentle, nor more profound, illustration of this truth than the slow, graceful unfolding of an autumn leaf. Imagine, if you will, a perfect maple leaf in late summer, a vibrant and brilliant green. It is a masterpiece of biological order, a tiny, intricate factory converting sunlight, water, and air into sugar. Its structure is complex, its chemistry is precise, its state is one of exceptionally low entropy. Then, as the season turns, the tree withdraws its resources, and the leaf begins its final, beautiful transformation. The green chlorophyll fades, revealing the brilliant yellows and fiery reds that were hidden beneath. It detaches from the branch and spirals gently to the forest floor. And there, its journey continues. Microbes begin their slow work, rain softens its structure, and the intricate architecture of its cells begins to break down. Its complex molecules are slowly, methodically, returned to the soil as simpler compounds. Its order gently dissipates, its stored energy spreads out, and its entropy steadily increases, until it is once again indistinguishable from the earth from which it grew. We can watch this entire process, from vibrant life to rich soil, and it feels natural, correct, and deeply familiar. It is the story of time's arrow, but we will never witness the reverse. We will never see the scattered molecules of soil and water spontaneously gather themselves together, weaving themselves into the intricate veins and tissues of a perfect leaf, which then leaps from the ground and reattaches itself to the branch, its colours fading from red and gold back to a vibrant summer green. Such an event is not strictly forbidden by the most fundamental laws of motion. It is merely so fantastically, so astronomically improbable that it would never happen in the entire lifespan of the universe, or in countless universes that might follow. The reason for this lies not in some grand cosmic decree, but in the quiet democracy of countless, tiny, mindless particles. This is the domain of statistical mechanics, the science that understands the whole by observing the behavior of the crowd. The fate of the leaf is not determined by a single, powerful force, but by the combined, random jostling of trillions upon trillions of atoms. Each individual atom is just bouncing around, following simple rules, with no knowledge of the past or the future. But together, their collective behavior creates a powerful and predictable trend. Imagine releasing a single drop of dark blue ink into a crystal clear glass of water. At first, it is a single, beautifully ordered sphere. But then, the individual water molecules, in their constant, random motion, bump into the ink molecules. They jostle them, pushing them one way and then another. Slowly, inexorably, the ink spreads. Delicate blue tendrils unfurl and drift through the water, becoming fainter and more diffuse, until the entire glass is a uniform, pale blue. The system has moved from a state of order, ink here, water there, to a state of disorder, where everything is mixed together. The number of ways the molecules can be perfectly separated is tiny compared to the googles of ways they can be mixed. And so, they mix. The arrow of time is simply the path of highest probability, the route that the universe follows because there are infinitely more ways to go forward, toward disorder, than to go back. This gentle, statistical unfolding that we witness in a decaying leaf or a diffusing drop of ink is the same process that governs the cosmos on the grandest of scales. Every star in the night sky, including our own sun, is a magnificent bastion of low entropy, a highly ordered sphere of hot, dense gas. And every second, it pours its order out into the void in the form of disordered light and heat. It is, in essence, dissolving into the vast cold water of space, just like the drop of ink. The universe itself is on a one-way journey. Astronomers can see the embers of its beginning, a time of unimaginable order and density, and they can foresee its eventual end, a state often called the heat death of the universe. This future is not a fiery apocalypse, but a slow, silent, and peaceful fading. A future trillions upon trillions of years from now, where all the stars have burned out, all the black holes have evaporated, and all that remains is a thin, cold, and perfectly uniform soup of elementary particles. A state of maximum entropy, of perfect and eternal equilibrium, where the river of time finally merges with the motionless ocean, and nothing ever happens again. But if the universe is constantly running down, like a wound-up clock slowly ticking its way to a standstill, it begs a profound question. Who wound up the clock in the first place? If the natural tendency of everything is to move towards disorder, then the universe must have started in a state of the most perfect, most astonishing order. This is perhaps the greatest mystery of all. The event we call the Big Bang was not just the beginning of matter and energy, but the beginning of order itself. The initial state of our cosmos, some 13.8 billion years ago, was one of incredibly low entropy. It was the cosmic equivalent of all the air in a room suddenly finding itself compressed into a space smaller than a single atom. It was the perfectly whole glass, the perfectly hot cup of tea, the perfectly organized cosmic bedroom. From that initial, pristine state of profound order, the entire history of the universe has been a story of unfolding, of spreading out, of entropy's gentle and continuous rise. Every galaxy that formed, every star that ignited, every planet that cooled, and every autumn leaf that fell to the forest floor has been a part of this grand, irreversible cascade, a ripple spreading outward from that first, impossibly ordered moment. And so the arrow of time, the very flow of our existence, points away from that beautiful singular beginning, drawing its relentless momentum from the slow and steady unraveling of that initial cosmic perfection. From that first, impossibly ordered moment at the dawn of existence, the grand story of the cosmos has been one of a slow and steady unraveling, a beautiful and complex tapestry woven from the simple thread of rising entropy. The universe has been breathing out for 13.8 billion years, its initial perfection dissolving into the magnificent complexity of galaxies, stars, and planets. And on one of these planets, our own Earth, this cosmic arrow of time has written a history so vast, so deep, that it defies our everyday comprehension. We are accustomed to measuring our lives in days and years, in the span of a single human life, or the recorded history of our civilizations. But to truly feel the flow of time, we must learn to quiet our minds and listen to a much slower, deeper rhythm, the silent, patient breathing of stone. This is the realm of deep time, a timescale not of centuries, but of eons. If the entire 4.5 billion year history of our planet were to be compressed into a single calendar year, the first multi-celled life would not appear until sometime in September. The dinosaurs would roam the Earth in the middle of December and vanish around Christmas Day. The whole of recorded human history, from the first cave paintings to the very moment you are hearing my voice, would occupy only the last few seconds before midnight on New Year's Eve. To contemplate this is to feel a profound sense of calm, a release from the urgency of our fleeting moments, and to recognize that we are a part of a story of almost unimaginable length and grandeur. The great book of this story is the Earth itself, and its pages are the layers of rock beneath our feet. This science of reading these pages is called stratigraphy. If you have ever driven past a deep road cutting through a hillside, or stood at the edge of a vast canyon like the Grand Canyon in the United States, you have seen the edges of these pages. Each distinct band of color and texture, each stratum, is a chapter in Earth's autobiography. A dark layer of shale might tell of a time when this land was the floor of a deep, quiet ocean, where fine mud settled slowly over millions of years. A thick band of sandstone might speak of a vast desert of shifting dunes, baked under an ancient sun. A seam of black coal is the compressed ghost of a lush, tropical swamp that flourished for an age and then was buried. Each layer is a world unto itself, a snapshot of a time gone by, and as we dig deeper, we travel further into the past. The fossils captured within these layers are the illustrations in this great stone book, the preserved remains of creatures who lived and died in these long-vanished worlds, their existence a testament to the ceaseless, forward march of life and time. But how do we know the age of these pages? How can we place a date on a time before calendars, before humans, before even the moon had settled into its familiar face in our sky? The answer lies in a kind of timekeeping more fundamental and more reliable than any clock we have ever built. It lies within the atoms themselves. This method, known as radiometric dating, relies on the beautifully predictable process of radioactive decay. Certain elements in nature, like uranium or potassium, are unstable. Their very essence is in a state of slow transformation. Over immense periods, an atom of uranium-238 will, for example, decay into an atom of lead-2O6. This process is like the slow, steady burning of a candle. We may not know exactly when a single specific atom will make this change, but we know with incredible precision how long it takes for half of a large collection of these atoms to do so. This period is called a half-life, and it is an unchangeable, fundamental constant of nature. The half-life of carbon-14, for example, is about 5,730 years, which makes it perfect for dating organic remains from our more recent past. The half-life of uranium-238, however, is about 4.5 billion years, roughly the age of our planet, making it the perfect clock for reading the deep history of the rocks. When a volcanic rock first cools and solidifies, it locks within it a certain number of these unstable parent atoms. From that moment, the clock starts ticking. The parent atoms begin their slow, steady decay into daughter atoms. By carefully measuring the ratio of parent atoms to daughter atoms in a rock sample today, scientists can calculate with remarkable accuracy how many half-lives have passed, and thus, precisely when that rock was born. It is through these atomic clocks, ticking silently within the heart of the stone, that we have pieced together the epic, billion-year story of our world. And this story is one of constant, slow-motion change. The very ground beneath us is not solid and eternal, but a mosaic of colossal plates, floating and drifting on a sea of molten rock, a process we call plate tectonics. Continents waltz across the globe at the speed that your fingernails grow, crashing into one another to raise up mountain ranges like the Himalayas, and pulling apart to open new oceans. This is the planet's own metabolism, its own expression of the arrow of time, driven by the escape of its primordial, ordered heat from its core out into the cold of space. The slow breathing of stone, the rise and fall of mountains, the opening and closing of seas, is all part of that same universal journey, from order to disorder, that began with the universe itself. The Earth is not a dead stage upon which the story of time unfolds. It is an active participant, a living, breathing entity whose history is written in the very structure of its bones, a history that continues to be written, one grain of sand, one layer of stone, one slow breath at a time. The slow, deep breathing of the planet, measured in the rise and fall of mountains over millions of years, provides the grand, quiet stage for our existence. But for life itself, time is a much more intimate and immediate affair. The same arrow of time that carved the canyons and drifted the continents also sculpted the creatures that inhabit this world, bestowing upon them their own internal clocks, their own inner tides that ebb and flow in harmony with the turning of the earth. From the simplest bacterium to the most complex mammal, life does not merely exist in time, it is saturated with time. It has learned to anticipate the daily cycles of light and dark, the seasonal shifts from warmth to cold, and the unyielding progression from birth to death. The study of this beautiful and intricate relationship between life and time is known as chronobiology, and it reveals that every living thing is, in its essence, a remarkable timepiece, a symphony of interconnected rhythms. Think of the way a flower, like a morning glory, opens its petals to the dawn and closes them at dusk, or how a bear instinctively knows when to retreat into the deep slumber of hibernation as winter approaches. These are not merely passive reactions to the environment, they are proactive, internally driven rhythms that have been encoded into the very fabric of life by billions of years of evolution. Life learned early on that the world was a predictable, cyclical place, and that there was a tremendous advantage in being able to anticipate its changes, rather than just react to them. The most profound and pervasive of these rhythms, the one that governs our own lives most deeply, is the circadian rhythm. The word circadian comes from the Latin circadium, meaning about a day, and it refers to the roughly 24-hour cycle that acts as the master tempo for our physiology and behavior. It is the invisible conductor that cues the release of hormones, regulates our body temperature, and dictates our cycles of sleep and wakefulness. Long before you feel the conscious desire for sleep, your internal circadian clock has already begun preparing your body for rest, lowering your core temperature and releasing the hormone melatonin to signal the coming of night. And hours before your alarm clock might ring, this same internal timer begins to prepare you for the day, raising your temperature and releasing cortisol to promote alertness. We are creatures of the dawn and the dusk, our bodies still dancing to a rhythm that was set when our most ancient ancestors first registered. The difference between the sunlit safety of day and the predatory darkness of night. This is not just a psychological preference, it is a deep biological imperative, a legacy written in our genes. So, where does this remarkable conductor reside? Where is the master clock that keeps our entire bodily orchestra in time? Deep within the brain, nestled in a region of the hypothalamus, just above where the optic nerves cross, lies a tiny, elegant cluster of about 20,000 neurons called the suprachiasmatic nucleus, or SCN. It is no larger than a grain of rice, but it is the central pacemaker for the entire body. Its location is no accident. It receives direct input from the eyes, allowing it to synchronize our internal day with the external day of the world. Each morning, the first photons of sunlight that strike your retina send a signal directly to the SCN, effectively resetting the clock and telling it, a new day has begun. From its command center, the SCN then sends out signals that coordinate the countless smaller clocks that exist in almost every organ and every cell of our bodies, ensuring that our liver, our heart, our digestive system, and our immune system are all working from the same temporal blueprint. It is a system of breathtaking elegance, a universe of timekeeping within each and every one of us. But the circadian rhythm is not the only clock our bodies keep. If the circadian cycle is the clock that measures our days, then our very genes contain a different kind of clock, one that measures the length of our lives. At the very tip of each one of our chromosomes, the tightly coiled threads of DNA that hold our genetic blueprint are protective caps called telomeres. You can think of them as being like the small plastic tips at the end of a shoelace, which prevent the lace from fraying and unraveling. In a similar way, telomeres protect our precious genetic information from degrading each time a cell divides. But here is the profound temporal twist. With each and every division of the cell, a tiny piece of the telomere is lost. They grow progressively shorter. This shortening acts as a kind of molecular clock, counting the number of times a cell has replicated. When the telomeres become critically short, the cell can no longer divide safely and enters a state of retirement, or senescence. This process is one of the fundamental mechanisms of aging. The steady, irreversible shortening of our telomeres is the arrow of time made manifest at the most intimate, molecular level of our being. It is a quiet, internal measure of our journey through life, a biological countdown timer that ensures our mortal story has a beginning, a middle, and an end. From the grand, planetary cycle of day and night internalized in our brains, to the finite, genetic countdown ticking away in the heart of our cells, our bodies are living chronicles of time, each breath, each heartbeat, a note in a song that began with the very first life on Earth, a rhythm that connects us to the ancient and eternal turning of the world. Our bodies are magnificent chronicles of time, their daily rhythms tuned to the turning of the planet, and their lifespan measured by the slow, steady shortening of our genetic code. We are biological clocks, intricately assembled by 4 billion years of evolution. And yet, the time our bodies keep is a silent, unconscious rhythm, a deep and steady drumbeat beneath the surface of our awareness. The time we truly experience, the time that shapes our lives, our joys, and our sorrows, is a far more mysterious and malleable thing. It is the time that is built, moment by moment, within the quiet, luminous architecture of the mind. Our journey now takes us inward, from the cellular clocks in our bodies to the great, subjective timekeeper of our consciousness, the human brain, which does not merely record time, but actively constructs it. The past, for us, is not a dusty archive of perfect recordings that we can access at will. Instead, the past is a ghost, a shimmering reconstruction that we summon into the present each time we remember. The act of remembering is a profoundly creative one. When you recall the memory of a happy afternoon in a sunlit park, your brain is not replaying a video. It is reawakening a specific pattern of neural connections that were forged during that experience. The brain's master architect in this process is a beautiful, seahorse-shaped structure deep within the temporal lobes called the hippocampus. It acts like a skilled weaver, taking the disparate threads of an experience, the sight of the green grass from your visual cortex, the sound of laughter from your auditory cortex, the feeling of warmth from your sensory cortex, and the emotion of joy from your amygdala, and binding them together into a single, coherent tapestry. A memory. This binding process happens through a subtle and elegant mechanism, a principle often summarized as neurons that fire together, wire together. The simultaneous activation of all those different brain regions strengthens the synaptic connections between them, creating a dedicated neural pathway. The memory, then, is not a thing stored in a single location, but a potential pattern, a resonance that can be re-excited, bringing the echo of the past into the present moment. What is so truly extraordinary is that the very same neural machinery we use to reconstruct the past is also what we use to imagine the future. Neuroscientists have discovered that when a person is asked to remember a past event and then asked to imagine a future event, the hippocampus and its associated networks light up in strikingly similar ways. This reveals a profound truth about our experience of time. Our vision of the future is built from the raw materials of our past. We rummage through the library of our memories, taking characters from one story, settings from another, and emotions from a third, and we splice them together to create a simulation of what might be. This ability for mental time travel, what is sometimes called prospective memory, is one of the defining traits of our species. It is the root of our ability to plan, to set goals, to invent, to tell stories, and even to feel anxiety or hope, for both are emotions rooted in a future that exists only in our minds. We live our lives guided by these ghosts of what has been and these dreams of what might be. This mental construction of time is also the reason for its strange and fluid elasticity. We have all experienced moments when time seems to stretch or compress, to fly by in an instant or to drag on for an eternity. An hour spent in joyful conversation with a loved one can vanish in a flash, while a single minute spent waiting for important news can feel like a lifetime. This is not just a feeling, it is a real phenomenon of our perception. When we are deeply engaged, happy, or learning something new, our brain is flooded with the neurotransmitter dopamine, which can affect our internal sense of timing, making it feel as though time is passing more quickly. Conversely, in moments of fear or mortal danger, the brain goes into a state of high alert. The amygdala, our threat detection center, kicks into overdrive, and we begin to record our experience in a much higher resolution, absorbing far more sensory detail than we normally would. When we look back on that terrifying moment, we have so much more data to process that the event feels as though it happened in slow motion. Time's perceived duration, then, is not measured by the tick of an external clock, but by the amount of information our brain processes. A week filled with routine and repetition may leave behind almost no distinct memories, and so it feels short in retrospect. A single day of travel to a new and exciting place, however, is packed with novel experiences and creates a rich tapestry of memories, making that one day feel long and full when we look back upon it. We build our personal history not from the seconds on the clock, but from the richness of the moments we truly live. And so, our consciousness sits like a great weaver at a loom, with the threads of our memories stretched out behind us and the unspun wool of possibility before us. With every passing moment, we weave these threads together, creating the unique, personal, and ever-unfolding narrative of our own life, a singular and precious tapestry against the vast, objective backdrop of cosmic time. Within the quiet loom of the mind, we weave our own personal experience of time, a rich tapestry of memories and dreams where moments can stretch and shrink according to the rhythm of our own awareness. We have always felt, intuitively, that this subjective experience was a trick of our consciousness, a purely internal phenomenon, while out there, in the real world, time was something absolute and universal. We imagined a great, cosmic clock that ticked at the same rate for everyone and everything in the universe, a master metronome that kept all of existence in lockstep. It was a simple, comforting, and deeply ingrained idea, and it was completely wrong. At the very beginning of the 20th century, a young patent clerk in Switzerland named Albert Einstein would gently unravel this universal assumption, and in doing so, would forever change our understanding of reality. He revealed that the flexible, personal nature of time was not just a feature of our psychology, but a fundamental property of the cosmos itself. Our journey now takes us away from the familiar shores of human perception and out into the deep, strange waters of relativity, beginning with a single, unshakable, and reality-bending fact: the speed of a sunbeam. For most of our history, we understood speed in a very simple way. If you are on a train moving at 100 kilometers per hour and you throw a ball forward at 20 kilometers per hour, someone standing on the platform would see the ball moving at 120 kilometers per hour. The speeds simply add up. It makes perfect sense. But light, Einstein realized, does not play by these rules. Light is the universe's ultimate speed limit, moving through a vacuum at a constant and staggering 299,792,458 meters per second. And here is the truly bizarre part: that speed is the same for everyone, no matter how they are moving. If you are standing still and you shine a flashlight, you will measure the light moving away from you at that incredible speed. If you are in a rocket ship traveling at half the speed of light, and you shine that same flashlight, you will still measure the light moving away from you at the exact same speed. The light from a star rushing towards our galaxy and the light from a star rushing away from it both arrive at our telescopes, traveling at precisely the same velocity. This simple, experimentally verified fact shatters our everyday intuition. In order for the speed of light to remain constant for all observers, something else, something we thought was fundamental and unchangeable, must be flexible. That something, Einstein proposed, was space and time. He asked us to stop thinking of space as an empty stage and time as a universal clock. Instead, he invited us to see them as two aspects of a single, interwoven continuum, a four-dimensional fabric he called space-time. Every object in the universe is moving through this space-time. And here is the key insight. The faster you move through the dimensions of space, the slower you must move through the dimension of time. This effect is known as time dilation. To visualize this, imagine a clock that works by bouncing a pulse of light between two mirrors. If you are holding this clock and are stationary, the light simply travels up and down, and each round trip is one tick. Now, imagine your friend is holding this same clock on a spaceship flying past you at an incredible speed. From your perspective, you see the light in their clock traveling not just up and down, but also forward. It has to trace a longer, diagonal path to get from one mirror to the other. But since the speed of light must be exactly the same for you as it is for your friend, and since the path you observe the light taking is longer, there is only one possible conclusion. Your friend's clock must be ticking more slowly than yours. From your point of view, time itself has slowed down for them. And from their point of view, it is you who are moving, and so it is your clock that appears to be ticking more slowly. Time is no longer absolute. It is relative. This leads to the famous and beautiful thought experiment known as the twin paradox. Imagine two identical twins. One stays on Earth, while the other embarks on a journey to a distant star in a rocket that travels near the speed of light. After many years, the traveling twin turns around and returns to Earth. When she steps out of her spacecraft, she will find that she has aged only a few years, while her twin on Earth has aged many decades. She is physically and biologically younger than her twin. This is not science fiction. It is a direct and proven consequence of the way our universe is built. Astronauts on the International Space Station, orbiting the Earth at over 27,000 kilometers per hour, experience this effect. They age ever so slightly slower than we do on the surface, a tiny fraction of a second over their months in orbit, a difference that is measurable with our incredibly precise atomic clocks. The implication is profound and deeply personal. There is no single, universal now that is shared by everyone. Each of us is traveling on our own unique path through the four dimensions of space-time, and as a result, each of us carries our own personal clock, experiencing our own unique flow of time. The rate at which we journey into the future is not a constant, but a variable, a personal rhythm dependent on our own motion through the cosmos. The river of time has fractured into billions upon billions of individual streams, each one flowing at its own pace, weaving a story of reality far richer and stranger than we ever could have imagined. The universe, as revealed by Einstein's gentle revolution, is a place where time is not a universal metronome, but a collection of billions of personal streams, each flowing at its own pace, its tempo dictated by its journey through space. This fracturing of a single, absolute time into a multitude of relative ones was a staggering revelation. But Einstein's contemplation did not stop there. He sensed a missing piece in this beautiful new picture of reality. Special relativity had described the dance of time and space on a flat, unchanging stage. But what was the force that choreographed this dance? What was the great, silent influence that governed the motion of the planets and the stars? That influence was gravity. And in his quest to understand it, Einstein would discover that gravity does not just influence the objects within spacetime, it shapes the very fabric of spacetime itself. He would show us that a moment does not just pass, a moment can curve. To understand this, we must once again let go of our familiar notions of space as an empty void. Instead, let us visualize the four-dimensional continuum of spacetime as a vast, invisible, and flexible fabric, a cosmic trampoline stretching to the edges of infinity. In a completely empty universe, this fabric would be perfectly flat and taut. Time would flow at the same rate everywhere, and objects would travel in perfectly straight lines forever. But our universe is not empty. It is filled with matter and energy, with galaxies, stars, and planets. And according to Einstein's theory of general relativity, mass tells spacetime how to curve, and the curvature of spacetime tells mass how to move. Imagine placing a heavy bowling ball in the center of our cosmic trampoline. Its weight creates a deep, sloping depression in the fabric. This is what a massive object, like our sun, does to the spacetime around it. It creates what we call a gravity well. Now, imagine rolling a small marble nearby. The marble doesn't get pulled towards the bowling ball by some mysterious, invisible string. Instead, it simply follows the curve in the fabric. It rolls down into the depression, its path bent by the shape of the surface. If you give it just the right speed, it will settle into a stable path, circling the bowling ball in a continuous loop. This is an orbit. This is what gravity is. It is not a force in the traditional sense. It is the geometry of the universe. The Earth is not being pulled by the Sun. It is following the straightest possible path through the curved spacetime that the Sun's immense mass has created. We are all, at this very moment, sliding along the gentle, invisible contours of the gravity well created by our planet. This is a beautiful and profound shift in perspective. The silent, cosmic dance of the planets is not governed by mysterious forces, but by the elegant and predictable warping of the universe's very stage. But what does this have to do with the flow of time? Everything. If time is an inseparable part of the spacetime fabric, then any curvature in that fabric must affect not just the three dimensions of space, but also the single dimension of time. This effect is known as gravitational time dilation. The rule is simple and beautiful. The stronger the gravity, the slower the pace of time. The deeper you are within a gravity well, the more sluggishly the river of time flows. This is not a metaphor. It is a physical reality. A clock at sea level, closer to the center of the Earth's mass and deeper in its gravity well, will tick ever so slightly more slowly than an identical clock placed on top of a mountain. An observer on the mountaintop would, if they could measure with enough precision, see the entire world in the valley below them, living its life in a subtly slower motion. The difference is infinitesimal in our everyday lives, but it is real, and it has been measured with astonishingly accurate atomic clocks. Our planet, orbiting the Sun, is constantly passing through a region of spacetime where time flows more slowly than it does in the empty space between the stars. The entire history of our world has unfolded in a slightly time-dilated state, a gentle eddy in the cosmic river. For a long time, this wondrous idea remained in the realm of theoretical physics, a beautiful but seemingly esoteric truth about the universe. But today, the curving of a moment is a practical and essential piece of engineering that you may use every single day. The Global Positioning System, or GPS, that so many of us rely on for navigation, is a network of satellites orbiting high above the Earth. These satellites carry incredibly precise atomic clocks. But because they are orbiting at an altitude of about 20,000 kilometers, they are in a much weaker gravitational field than we are on the surface. As a result, their clocks run faster than our clocks down here by about 45 microseconds every single day. At the same time, because they are moving at high speeds, their clocks are also slowed down by the effects of special relativity by about 7 microseconds a day. If the engineers who designed the GPS system did not account for both of these relativistic effects, if they did not understand that time itself flows at a different rate in orbit than it does on the ground, the system would be utterly useless. The positional errors would accumulate at a rate of roughly 10 kilometers every single day. The fact that your phone can tell you your location with pinpoint accuracy is a daily, tangible proof that we live in a universe where time is not absolute, a universe where moments can be bent and warped by the silent, graceful weight of a star or a planet. The cosmos is not a rigid, clockwork machine, but a dynamic, flowing landscape, a geography of warped time and curved space through which we all drift, silently following the contours of eternity. We drift together through this flowing cosmic landscape, where the fabric of space-time is warped into gentle valleys by the presence of stars and planets, causing the river of time to slow its pace as it passes through them. These gravitational wells are the harbors where life can form, where worlds can have a stable history. But what happens if we follow these curves to their most extreme conclusion? What happens if an object is so massive, so incredibly dense, that the valley it creates in spacetime is not just a gentle depression, but a sheer, vertical, and bottomless chasm. When this happens, the universe gives birth to its most mysterious and enigmatic creation, an object that is not really an object at all, but a place, a region of spacetime so profoundly curved that it rips a hole in the very map of reality. This is the place we call a black hole. The story of a black hole begins with the death of a truly colossal star, a star many times more massive than our own sun. For millions of years, this star lives in a state of delicate balance. The immense, outward pressure generated by the nuclear fusion in its core holds back the relentless, inward crush of its own gravity. But eventually, the star exhausts its nuclear fuel. The fire in its heart goes out, and in that instant, the balance is broken. Gravity, the silent and patient victor, wins. In less than a second, the star's core collapses in upon itself, in a cataclysm of unimaginable violence. An amount of mass many times greater than our sun is crushed into a space smaller than a city, then smaller than a mountain, then smaller than a single grain of sand, until it is compressed into a point of theoretically infinite density, a gravitational singularity. This final, catastrophic act of compression punches a hole in the fabric of spacetime itself. The result of this collapse is the creation of a boundary in space, a perimeter of no return, known as the event horizon. It is not a physical surface you could touch, but rather a threshold in spacetime. It is the shore of an eternal ocean. Outside the event horizon, escape is still possible, if difficult. But once you cross that invisible line, your future is sealed. The curvature of spacetime inside the event horizon is so extreme that all possible paths, every direction you could possibly move, lead only inward, towards the central singularity. The escape velocity from within this boundary is greater than the speed of light, and since nothing in the universe can travel faster than light, nothing that crosses the event horizon can ever escape. Not a spaceship, not a planet, not even a single sunbeam. This is why they are called black holes. They are the ultimate cosmic prisons from which not even light can send us a message. And here, at this shore of eternity, time behaves in the most peculiar way imaginable. Imagine you are in a safe, distant spacecraft, watching a brave astronaut journey towards a black hole. As your friend gets closer and closer to the event horizon, you would witness the effects of extreme gravitational time dilation. The light signals from their ship would become stretched, shifting towards the red end of the spectrum. Their movements would appear to become slower and slower. Their clock would seem to tick at a near standstill. To you, your friend would appear to slow down, to dim, and to freeze at the edge of the event horizon, their image smeared across its surface for all of eternity, never quite crossing over. But for the astronaut, time would feel perfectly normal. They would feel no jolt, no barrier as they crossed the event horizon. They would simply float across the invisible line, their own clock ticking normally, and enter a region of space from which they could never return. Their timeline now destined to end in the central singularity, where our known laws of physics and our very concepts of time and space come to a complete and silent end. For many years, it was thought that this was the end of the story, that black holes were perfect, eternal sinks, consuming matter and information from the universe forever. But then, the brilliant physicist Stephen Hawking made a discovery that added a final, beautiful layer of mystery. By combining the laws of general relativity with the strange rules of quantum mechanics, he realized that black holes are not perfectly black after all. He showed that due to subtle quantum fluctuations at the very edge of the event horizon, black holes should emit a faint, constant stream of particles. This steady glow is now known as Hawking radiation. This means that a black hole has a temperature, albeit an incredibly cold one. It also means that in emitting this radiation, the black hole is very, very slowly losing mass. This process of evaporation is fantastically slow. For a black hole the mass of our sun, it would take longer than the current age of the universe has existed by many, many orders of magnitude. But it means that they are not eternal. Over unimaginable, near-infinite timescales, they will eventually radiate all of their mass away until they disappear in a final, gentle flash of light. They are not cosmic prisons, but merely the most patient and long-lived entities in the cosmos, silent monuments to the awesome power of gravity, holding their secrets until the very end of time. They mark the place on the map where time as we know it ceases to be, a quiet, dark shore on the ocean of what we do not, and perhaps cannot know. We have journeyed together to the very edge of comprehension, to the silent, dark shore of a black hole, where time itself stretches into an infinite stillness, and the laws of our universe fall away into a singularity. This is the ultimate fate of collapsed matter, a possible endpoint for the far, far future. And now, from this final, quiet shore, let us cast our minds in the opposite direction. Let us journey back, past the formation of the earth, past the birth of the first stars, past the cooling of the first atoms, to the very beginning of the river of time itself, to another singularity, the one from which all of creation sprang forth. This is the event we call the Big Bang, a name that is both famously evocative and somewhat misleading. For the Big Bang was not an explosion in space, like a bomb going off in an empty room. It was the beginning of space itself. It was not something that happened in the universe. It was the event that brought the universe into being. The most helpful way to visualize this is to imagine the entire three-dimensional space of our cosmos as the two-dimensional surface of a balloon. If you draw small dots on this balloon to represent galaxies, and then begin to inflate it, you will notice that every dot moves away from every other dot. There is no central point of the expansion on the surface of the balloon. The expansion is happening everywhere at once. The galaxies are not flying through space away from each other. The very fabric of space between them is stretching, carrying them along for the ride. Our universe has been inflating like this for 13.8 billion years, expanding from a state of unimaginable density and heat. As we rewind this cosmic expansion, traveling backward in time, the universe becomes hotter, denser, and smaller. Let us go back as far as our physics can possibly take us, to the very first sliver of a moment, a period known as the Planck epoch. This is the universe in its first 10 to the power of negative 43 seconds of existence, a duration so fantastically short that it is, for all intents and purposes, the fundamental quantum unit of time. In this primordial era, the entire observable universe was compressed into a space billions of times smaller than a single proton. The temperature and energy were so extreme that the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces were believed to be merged into a single, unified superforce. This was a realm where our known laws of physics ceased to make sense, a roiling, energetic quantum foam where space and time, as we understand them, had not yet crystallized into a coherent reality. This is the true edge of our knowledge, a time before time, a state of pure, undifferentiated potential from which everything we know would eventually emerge. From this indescribable beginning, the universe began its expansion and cooling. Let us move forward now, to a time just 3 minutes after the Big Bang. The universe has cooled enough for the most basic building blocks of matter to form. In a brief, fiery crucible that filled the entire cosmos, protons and neutrons fused together to create the nuclei of the first elements. This process, known as Big Bang nucleosynthesis, forged almost all of the hydrogen and helium in the universe, along with a tiny trace of lithium. These simple, light elements would be the raw material from which every star, every planet, and every living being would one day be built. The chemical fate of the universe was sealed in its very first few minutes. For the next 380,000 years, the universe continued to expand and cool, but it remained an opaque and fiery place, a dense, glowing fog of plasma, where light was trapped, constantly scattering off free-roaming electrons, unable to travel any significant distance. It was a universe without a view. But then, a truly momentous transition occurred. The temperature dropped to a point where electrons could finally be captured by atomic nuclei, forming the first stable, neutral atoms. In an instant, the cosmic fog cleared. The universe, for the very first time, became transparent. The light that had been trapped within the plasma was now free to travel unimpeded through space, and that light has been traveling ever since. Today, 13.8 billion years later, that first tremor of light still fills the entire sky. The expansion of the universe has stretched its waves so much that it is no longer visible light, but has cooled into the microwave part of the spectrum. This is the cosmic microwave background, the CMB. It is the afterglow of creation, the oldest light in the universe. When astronomers point a radio telescope to any empty patch of sky, they can still see this faint, ancient glow, a near-uniform whisper of energy coming from every direction. It is a stunning, direct photograph of the infant universe, a snapshot of the moment it took its first breath of transparency, a silent testament to our fiery, luminous, and impossibly ordered beginning. From that first, luminous tremor of light, a vast and simple cosmic canvas was unfurled, a universe filled with near-uniform clouds of hydrogen and helium, bathed in the gentle, fading afterglow of its own creation. We have seen time on this grand cosmological scale, flowing smoothly and inexorably for billions of years, its gentle current carrying galaxies along with it. We have seen it on the geological scale, breathing slowly through stone, and on the biological scale, ticking within our very cells. But now our journey must take another turn, from the impossibly large to the impossibly small. We must ask a deeper question about the very nature of the river of time itself. From a distance, its surface appears perfectly smooth, continuous, and unbroken. But what if we could zoom in, far closer than any microscope could ever take us, to the most fundamental level of reality? Is the fabric of spacetime truly a seamless continuum? Or is it, like so much else in our universe, woven from discrete, indivisible threads? Is the flow of time a smooth and gentle slope, or is it a staircase made of an infinite number of unimaginably tiny steps? This question takes us into the strange and beautiful world of quantum mechanics. The classical world we are used to, the world of billiard balls and orbiting planets, is a world of continuity. An object can have any speed, any position, any energy, but as we venture into the subatomic realm, the rules change. Here, many properties are quantized, meaning they can only exist in discrete, specific amounts, or packets, called quanta. An electron orbiting an atom, for example, cannot have just any energy. It can only occupy specific energy levels, like a person standing on the rungs of a ladder, unable to float in between. The quantum world is not a smooth ramp. It is a staircase. This naturally leads us to wonder about time itself. Is it the one property of the universe that remains smooth and continuous? Or is it too, at its most fundamental level, a staircase? Does time flow, or does it tick? The idea that time might be quantized was first explored by the physicist Max Planck, and from his work, we get the concept of Planck time. This is not just a very, very short period. It is the shortest possible duration of time that has any physical meaning according to our current theories. It is a length of time so infinitesimally brief that it is difficult for the human mind to grasp. It is roughly 10 to the power of negative 43 seconds. To put that into perspective, there are more units of Planck time in a single second than there have been seconds in the entire history of the universe since the Big Bang. Below this fundamental scale, our notions of time, and even of cause and effect, may simply cease to apply. It is the ultimate frame rate of reality. This leads to a beautiful and profound possibility, that the smooth, flowing passage of time we experience is an illusion, an emergent property of these countless, discrete ticks happening at an impossibly fast rate. Our universe may be like a motion picture, a sequence of still frames being projected so rapidly that they create the seamless perception of continuous movement. Each tick of this cosmic clock, each frame of this universal film, would be one unit of Planck time. If time and space are quantized in this way, what does the fabric of space-time look like at this ultimate, microscopic level? The smooth, gently curving sheet of Einstein's relativity gives way to a far wilder and more chaotic picture. This is the speculative, yet mathematically plausible, realm of quantum foam or space-time foam. At the Planck scale, space-time is thought to be a turbulent, roiling sea of energy. The uncertainty principle of quantum mechanics which states that we can never know both the precise position and momentum of a particle, applies to spacetime itself. This means that space and time are not definite and still, but are constantly fluctuating. For incredibly brief moments, tiny bubbles of spacetime, microscopic wormholes, and even fledgling universes might be constantly popping in and out of existence, a seething, chaotic dance that underlies the calm, orderly cosmos we observe. The smooth geometry of the universe we see on a large scale would be just the average, placid surface of this deep, churning quantum ocean. The very ground of being, the fabric of reality itself, might be this chaotic, energetic foam from which the stable world we know emerges. Whether time is ultimately smooth or jittery, a river or a series of discrete droplets remains one of the deepest unanswered questions in all of physics. It lies at the frontier where our two greatest theories of the universe, general relativity, which describes the large and the smooth, and quantum mechanics, which describes the small and the quantized meet, and have yet to be reconciled. The answer awaits a future theory, a theory of everything that can finally weave them together. But as you rest here tonight, it is a peaceful thought that beneath the silent, steady flow of the moments you perceive, there may be a deep and hidden hum, a fundamental, impossibly fast quantum rhythm that beats as the secret heart of the universe, a silent vibration that animates every single second of existence. Beneath the smooth and steady flow of the moments we perceive, we have discovered a deep and hidden hum, a fundamental quantum rhythm that ticks at the base of reality. The very fabric of space-time, at its finest scale, may be a jittery, chaotic foam, and the passage of time may be the projection of countless, discrete frames, each lasting for only an infinitesimal fraction of a second. This journey into the quantum realm has reshaped our understanding of the texture of time, and now it will reshape our understanding of its direction, of the very nature of the future itself. In the classical world of our everyday experience, the world described by Isaac Newton, the future felt like a destination that was already there, waiting for us. If you knew the precise position and momentum of every particle in the universe, you could, in principle, calculate the entire future with perfect accuracy. The universe was a great and intricate clockwork, and the future was already written, merely waiting to be revealed. But the quantum world dismantled this deterministic dream, replacing it with something far more mysterious, uncertain, and, in many ways, more beautiful. It suggests that the future is not a single, pre-written path, but a shimmering garden of forking paths, a landscape of pure potential. At the heart of this new vision is the concept of quantum superposition. In our world, an object is in one definite state at a time. A light switch is either on or off. A coin, once flipped, is either heads or tails. But in the quantum realm, before an observation is made, a particle like an electron can exist in a superposition of all of its possible states simultaneously. An electron can be in multiple locations at once. An atom can be in a state of both having decayed and not yet having decayed. It exists not as a single, concrete reality, but as a haze of possibilities, a wave of potential. The most famous, though perhaps unsettling, illustration of this idea is the thought experiment of Schrödinger's cat. A cat is placed in a box with a radioactive atom that has a 50% chance of decaying in an hour. If it decays, it triggers a mechanism that releases a poison, and the cat perishes. If it does not decay, the cat remains alive. According to a strict quantum interpretation, until we open the box and make an observation, the atom is in a superposition of both having decayed and not having decayed. And therefore, the cat, its fate tied to the atom, is in a state of being both 100% alive and 100% dead at the same time. It is a strange and counterintuitive image, but it highlights the profound weirdness of the quantum world. Reality, at its most fundamental level, seems to be a cloud of overlapping possibilities until it is observed. This leads to one of the deepest mysteries in all of science, known as the measurement problem. What happens in that moment of observation? When we open the box, when we measure the electron's position, this haze of potential seems to instantaneously collapse into a single, definite reality. The wave of possibilities crystallizes into a single, actual particle. The cat is found to be either alive or dead. The universe seems to make a choice out of all the available options. The mathematical tool that describes this cloud of possibilities is called the wave function. It is an equation that represents the superposition of all possible states and allows us to calculate the probability of finding the particle in any one of those states upon measurement. The moment of observation, this strange and powerful transition from many possibilities to one actuality, is called the collapse of the wave function. But no one knows precisely how or why this collapse occurs. Does consciousness itself play a role? Is it a random, inherent feature of the universe? Or is it something else entirely? It remains a profound and unanswered question, but its implication for the nature of the future is immense. If the fundamental particles that make up our world exist as waves of probability until they interact with something, then the future itself is not a fixed and certain thing. The future is an unwritten, probabilistic haze. It is a vast ocean of potential wave functions, waiting to collapse into the reality of the present moment. The arrow of time, then, is not just a journey along a preordained road. It is the very process of that road being paved, moment by moment, out of the raw material of quantum uncertainty. Every quantum interaction, happening trillions upon trillions of times per second in every corner of the cosmos, is a point where one path is chosen from an infinitude of possibilities. The seemingly solid and predictable world we inhabit is an emergent property, a statistical average of this deep, underlying game of chance. The future is not a destination we are traveling to, but a reality we are co-creating, one quantum collapse at a time. The present moment, this beautiful, luminous now, is the ever-advancing shoreline, where the shimmering ocean of quantum possibility crystallizes into the solid ground of classical reality. The present moment, we can now imagine, is the delicate, crystallizing shoreline, where the vast ocean of quantum possibilities collapses into the single, solid reality we experience. The future is not a fixed landscape, but a shimmering wave of probability, and the passage of time is the continuous process of this wave becoming the shore. But what is truly happening in this act of crystallization? When a possibility becomes an actuality, what has changed in the universe? One of the most profound ways to think about this is through the lens of information. Before we open the box, our knowledge of the cat's state is uncertain. It is a mix of two possibilities. The moment we open the box, that uncertainty vanishes. We gain information. The collapse of the wave function is an act of information coming into being. This idea that information is not just an abstract human concept but a fundamental and physical component of the universe has revolutionized our understanding of reality. For centuries, we thought of the world as being made of matter and energy. But a new trinity has emerged: matter, energy, and information. And information, it turns out, is deeply and inextricably linked to the very arrow of time we have been exploring since our journey began. This connection brings us back to our old friend, entropy. As we discovered, the second law of thermodynamics states that the entropy, or disorder, of the universe always increases. A tidy room, a low entropy state, is simple. It contains very little information because its description is short. Everything is in its proper place. A messy room, a high entropy state, is complex. It contains a great deal of information, because to describe it fully, you would need to specify the location of every single scattered object. As a system evolves over time, its entropy increases, and so does the amount of information required to describe it. The arrow of time is also an arrow of increasing information. The link between these two concepts was made concrete and physical by a principle discovered by the physicist Rolf Landauer in the mid-20th century. He was contemplating the ultimate physical limits of computers and asked a simple question: is there a minimum amount of energy required to perform a computation? He discovered that most computational steps can, in theory, be done with no energy cost at all. But there was one exception: the act of erasing a bit of information. Landauer's principle states that whenever a single bit of information is erased, a tiny but irreducible minimum amount of energy must be dissipated into the environment as heat, To erase information is to reduce the number of possible states a system can be in, which is a decrease in entropy in the computer's memory. Therefore, to satisfy the second law of thermodynamics, that entropy must be paid for, released as a corresponding puff of heat into the surroundings. This was a monumental discovery. It proved that information is not just a mathematical abstraction. It is a physical quantity, as real as mass or energy, bound by the fundamental laws of the cosmos. There is a physical cost to forgetting. This idea of information as a core ingredient of reality has led to some of the most mind-bending and beautiful theories in modern physics, such as the holographic principle. Championed by physicists like Gerard Hooft and Leonard Susskind, this principle arises from the study of black holes. It suggests, in essence, that all of the information contained within a three-dimensional volume of space, every star, every planet, every atom can be fully described by the information encoded on its two-dimensional boundary, like a hologram which stores a three-dimensional image on a flat piece of film. This speculative but mathematically powerful idea suggests that the three-dimensional world we experience might be a projection, a holographic illusion generated by information stored on a distant, two-dimensional cosmic surface. Whether this is true or not, it deepens the idea that the universe, at its heart, can be understood as a structure of information. This leads us to a final, grand contemplation for tonight. Perhaps the universe is not a collection of things, but a process. Perhaps it can be best understood as a great and majestic computation. The state of the universe at the Big Bang was the initial input, a state of incredible simplicity and low information. The laws of physics are the algorithm, the set of rules that govern how the information is processed, and the unfolding of the entire history of the universe. Every star that is born, every galaxy that collides, every quantum wave that collapses, is the result of this cosmic program running, processing information, and computing the next moment of reality. The arrow of time, in this view, is the progression of the computation itself, moving from one state to the next. The universe is telling itself a story, writing its own existence into being, one computational step, one quantum bit at a time. And we, as conscious and observing parts of this universe, are both characters in the story and the means by which the story, for a fleeting moment, becomes aware of itself. We have imagined the universe as a grand and ongoing story, a cosmic computation that writes its own existence into being with every passing moment, with every collapse of a quantum wave. The present is a constantly advancing frontier, where the unwritten pages of the future are filled with the ink of reality. This is a dynamic and beautiful vision of time. But there is another, equally profound and deeply calming way to contemplate the nature of existence, an idea that arises directly from the equations of relativity and offers a stillness that is as vast as the cosmos itself. It asks us to consider a radical proposition. What if the book is already written? What if all the pages, from the first chapter to the very last, already exist together in their entirety? What if our journey through time is not the creation of a story, but simply the act of reading it, one page at a time? This is the vision of the universe known as the block universe, or eternalism. It invites us to see time not as a flowing river, but as a frozen landscape, a dimension just as real and as traversable, in principle, as the three dimensions of space. We are used to thinking of objects having extension in space. A road has length, a table has width, a mountain has height. The block universe model asks us to imagine that we, and everything in the cosmos, also have an extension in time. You are not just the person you are in this present moment. You are a four-dimensional being, a space-time worm that stretches from the moment of your birth to the moment of your death. The person you were as a child and the person you will be in your old age are not gone or yet to come. They are simply different locations along your own personal timeline within this four-dimensional block. This perspective is sometimes called the B theory of time, and it stands in contrast to our intuitive A theory. The A theory, or presentism, is the story we tell ourselves every day. That the past is a collection of memories that no longer exist. The future is a set of possibilities that do not yet exist, and only the fleeting present moment is truly real. The B theory, however, suggests that the past, present, and future are all equally real. The distinction we make between them is not a fundamental feature of the universe, but a feature of our perception. Terms like now, yesterday, and tomorrow are like terms such as here, over there, or in the next town. They are indexicals, words whose meaning depends entirely on where and when the speaker is located. For a person in another city, your here is there over there. In the block universe, for a being in another century, your now is their distant then. All moments, like all places, have an equal claim to reality. While this may sound like a purely philosophical idea, it finds surprisingly strong support in the physics of Einstein's relativity. As we discovered, one of the key consequences of special relativity is that there is no universal, absolute now. The very idea of simultaneity is relative. Two observers moving at different speeds can disagree on the order of events that happen at different locations. An event that one observer sees as happening now could be in the past for a second observer and in the future for a third. This makes it very difficult to defend the idea that only one single present moment is real for the entire universe. If we cannot even agree on which slice of time is the present, how can it be the only one that truly exists? It is far simpler, from a physicist's point of view, to accept that all the slices, all the moments, are equally real. If this is true, if we are living in a universe where all of time exists simultaneously, then where does our powerful, undeniable feeling of the flow of time come from? Why does it feel so strongly as if we are moving from a fixed past into an open future? The block universe theory suggests that this feeling of passage, the flow of the river, is not a property of the river itself, but a product of our consciousness. Our awareness acts like a spotlight, moving along our world line within the four-dimensional block, illuminating one moment at a time and creating the subjective experience of a moving present. The past is not gone. We have simply moved our spotlight of attention away from it. The future is not unformed. It is just a part of the landscape that our spotlight has not yet reached. This perspective can bring with it a profound sense of peace. It means that every moment of your life has a permanent place in the fabric of reality. The moments of joy are not lost forever. They exist eternally in their coordinates in space-time. The people we have loved and lost are not erased. Their entire lives, from beginning to end, are forever woven into the great tapestry. The future is not a terrifying, uncertain void, but a landscape that already exists, waiting for our arrival. We can let go of the struggle against the passage of time and simply be present in the moment that our consciousness is currently illuminating, knowing that it, too, will take its eternal place in the magnificent, silent crystal of all moments. And so, we can imagine the whole of existence, from the first tremor of light at the Big Bang to the last fading ember of the final star, as a single, magnificent, and complete entity. A four-dimensional crystal of space-time, containing every event that ever was or ever will be. Our lives are but tiny, intricate threads within this eternal design, and our consciousness is a single point of light travelling along these threads, experiencing the moments one by one. This is the serene and majestic vision of the block universe. It is a universe of ultimate unity and permanence. But as we rest in this image of a single, perfect crystal, our journey into the quantum realm tugs at our minds with another, equally staggering possibility. We learn that every quantum event is a moment of choice, where a wave of possibilities collapses into a single, concrete reality. The block universe seems to suggest that all of these choices have already been made, that only one path through the garden of forking paths was ever taken. But what if that is not the case? What if the universe does not choose at all? What if, at every one of these quantum crossroads, reality does not select one path, but instead follows all of them? This is the breathtaking idea that fractures the single crystal of reality into an infinite, glittering collection of parallel skies. This is the multiverse. This concept finds its most direct expression in what is known as the many worlds interpretation of quantum mechanics, first proposed by the physicist Hugh Everett III. He offered a radical and strangely elegant solution to the measurement problem we explored earlier. He asked, what if the wave function never collapses? What if the cloud of possibilities never crystallizes into a single reality? Instead, Everett proposed that at every moment of quantum choice, the entire universe splits. All possible outcomes of the event do, in fact, happen, but each one happens in a separate, parallel branch of reality. When the radioactive atom in Schrödinger's box is in a superposition of decaying and not decaying, the universe itself cleaves in two. In one universe, the atom decays, the poison is released, and the cat perishes. In another, completely separate and parallel universe, the atom does not decay, and the cat lives on, blissfully unaware of its tragic counterpart in another branch of reality. You, as the observer who opens the box, also split. One version of you finds a living cat, and another version of you finds a dead one, and each of these versions of you believes that their reality is the only one. From this perspective, the universe is an endlessly branching tree. With every quantum event, new branches sprout, creating new worlds, new histories, new futures. We are living on just one of these branches, and our experience of a single, coherent timeline is simply our journey along this particular path. But existing in parallel, just beyond our perception, are countless other branches, countless other versions of ourselves, living out the consequences of every quantum choice that could have possibly been made differently. You may wonder, if these other worlds are real, why can we not see them or interact with them? The process that isolates these branches from one another is known as quantum decoherence. As soon as a quantum superposition interacts with its environment, a stray photon, a nearby air molecule, the different possibilities become entangled with the countless particles of that environment. This entanglement effectively smears the superposition out, making it impossible for the different branches to ever interfere with each other again. They decohere, splitting off into their own self-contained realities. The superposition is not destroyed. It is simply diluted across the universe, with each possibility evolving into its own independent world. In the many worlds view, there is only one, single, all-encompassing mathematical object, the universal wave function. It contains all the branches, all the possibilities, all the worlds. It never collapses. It simply evolves according to the elegant equations of quantum mechanics, its complexity growing with every passing moment, as the tree of reality sprouts more and more branches. Our entire universe, our personal history, is just one tiny sliver of this unimaginably vast, ever-growing structure. And the idea of a multiverse does not come from this one interpretation alone. It appears as a recurring possibility in several areas of theoretical physics. Some theories of cosmic inflation, the process that rapidly expanded our universe moments after the Big Bang, suggest that this inflation never entirely stops. It may be that our universe is just one bubble that nucleated and grew within a much larger, eternally inflating space, and that new bubble universes, perhaps with different fundamental laws of physics, are constantly being born. In this eternal inflation model, our cosmos is just one island in an infinite cosmic ocean of other universes. Other theories, like string theory, also suggest a vast landscape of possible universes, each with its own unique properties. The idea of parallel worlds, once the domain of pure fiction, is now a serious, if speculative, consideration at the forefront of science. And so we are left with a vision of existence that is almost too vast to hold in our minds. Our universe, perhaps our entire crystal of space-time, may be but one leaf on an infinite tree, one bubble in a cosmic foam, one echo among countless others in the parallel skies of a grand and boundless multiverse. From the serene but staggering vision of a single, perfect crystal of space-time, our contemplation has blossomed into the breathtaking possibility of an infinite, branching tree of realities. We have imagined our own universe as but one leaf on this tree, one echo in a sky filled with parallel worlds, each born from a quantum choice, each following its own unique history into its own unique future. It is a vision of boundless existence. But now, let us gently draw our awareness back from those other, unseen skies and return home. Let us return to our own familiar branch, to our own precious universe, the one that we can see and touch and be a part of. We have journeyed back to its fiery beginning, and now, To bring our great exploration of the cosmos to a gentle close, we must cast our gaze forward, as far as science and imagination can possibly see, to contemplate the ultimate, final destiny of our own universe. We must ask, how does our story end? As we peer into the deep future, cosmologists see several possible paths, several final chapters for our cosmos, and which path will be taken depends on the true nature of the mysterious, invisible energy that is currently driving our universe's accelerating expansion, an energy we call dark energy. The most likely scenario, based on our current understanding, is a future that is not fiery and violent, but rather one of a profound and ever-growing quiet. This destiny is known as the heat death of the universe, or the Big Freeze. It is the ultimate and final victory of the second law of thermodynamics. The story begins with the slow, graceful fading of the light. Over the next 100 trillion years, all the gas and dust that can form stars will have been used up. One by one, the great stellar furnaces will exhaust their fuel and go dark. The universe will become a vast and silent graveyard of stellar remnants. Cold, dense white dwarfs, incredibly compact neutron stars, and the silent, patient black holes. The galaxies themselves will become dark, ghostly collections of these dead stars. Then, on timescales that are almost beyond human comprehension, even these remnants will begin to decay. Protons themselves may eventually dissolve, and the supermassive black holes that sit at the heart of every galaxy will, through the faint whisper of Hawking radiation, slowly evaporate over googles of years, returning their locked-up energy to the cosmos in a final, gentle sigh. Eventually, after an amount of time so vast that our own universe's age would be a meaningless fraction of a second in comparison, all that will remain is a thin, cold, and perfectly uniform soup of elementary particles and faint radiation, spread evenly throughout an unimaginably large and still expanding space. The universe will have reached a state of maximum entropy, of perfect equilibrium. All the great structures will have dissolved, all the differences in temperature will have vanished, and all the clocks will have stopped. The river of time will have finally merged with a vast and motionless ocean, where nothing of consequence ever happens again. It is not an end in the sense of a destruction, but a final, peaceful, and eternal rest. There are other, more dramatic, though currently less likely, possibilities. One is known as the Big Rip. This fate depends on a particularly aggressive form of dark energy, sometimes called phantom energy, which would grow stronger over time. If this were the case, its repulsive force would eventually become so powerful that it would overwhelm everything. In the final stages of a Big Rip, the dark energy would first pull apart the great clusters of galaxies. Then, it would be strong enough to unbind the galaxies themselves, sending their dead stars flying off into the void. As its power continued to grow, it would overcome the electromagnetic forces holding atoms together, and then even the strong nuclear force holding atomic nuclei together. In the very last moments, the fabric of space-time itself would be torn asunder in a final, complete unraveling of reality. A third, more cyclical possibility is the Big Crunch. This would happen if the expansion of the universe were one day to slow down, stop, and reverse. Gravity would regain its dominance, and the universe would begin to contract. The great film of cosmic history would play in reverse. Galaxies would rush towards each other, merging in a fiery blaze. The temperature of the universe would rise, until stars and planets vaporized, atoms were stripped of their electrons, and all of creation collapsed back into a single, hot, dense point, a final singularity, much like the one from which it began. This scenario opens the beautiful, speculative possibility of a big bounce, where the final crunch could trigger a new Big Bang, giving birth to a new universe in an endless cycle of cosmic death and rebirth. The ultimate fate of our universe, whether it is to freeze, to rip, or to crunch, is one of the greatest unanswered questions in science, a secret held in the heart of dark energy. But as we stand at this far shore of time and contemplate these last embers of starlight, there is a deep peace to be found in the scale of it all, a sense of completion in knowing that our universe, like all great stories, will one day have its final, silent, and magnificent end. And so, we have stood at the edge of the end, contemplating the final, silent chapter of our cosmos, where the last embers of starlight fade into a vast and patient darkness. We have journeyed through the great sweeping story of the universe, from the first tremor of light to the final, quiet equilibrium. But now, as our grand tour of the external cosmos comes to a close, we must turn our attention to the greatest mystery of all. A mystery that is not out there in the distant galaxies, but is right here, in this very moment, within you. It is the mystery of the one who has been listening to this story. All of our contemplations of entropy, of relativity, of quantum mechanics, and of the fate of the universe have been acts of a conscious mind. And this raises the most profound question. How is it possible that a collection of atoms, forged in the hearts of long-dead stars and assembled into the intricate machine of a human brain, can be aware? How can this matter, this stardust, look out upon the universe and not only see it, but feel it, wonder about it, and know that it is a part of it? This is the great mystery of consciousness, the silent, luminous witness in the machine. This question is so profound that the philosopher David Chalmers has called it the hard problem of consciousness. He distinguishes it from what he calls the easy problems. The easy problems, though incredibly complex, are ultimately questions about function. How does the brain process sensory information? How does it control behavior? How does it store and retrieve memories? These are questions that neuroscience is steadily making progress on, mapping the intricate neural circuits that perform these tasks. But the hard problem is a question not of function, but of experience. Why does all of this complex information processing feel like anything at all from the inside? Why is there a subjective, qualitative, inner life? Why do you have a what it is like to be you? Why is the color red not just the processing of a certain wavelength of light, but the rich, ineffable experience of redness? Why isn't all of this just happening in the dark, without any awareness, like a very sophisticated computer running a program? This is the central, stubborn mystery. And while we do not have an answer, we can explore the beautiful and intricate structures that give rise to it. Neuroscience has discovered a remarkable network in the brain that seems to be closely linked to our sense of self. It is called the default mode network. This is a collection of brain regions that becomes most active not when we are focused on a task, but when our minds are at rest, free to wander, to daydream, to remember our past, or to imagine our future. It is the neural home of our internal narrative, the storyteller within that weaves our disparate experiences into the continuous, coherent story of a life. It is, perhaps, the biological seat of the witness, the part of us that experiences our journey through time. One of the most promising ways to think about how this inner world arises is through the concept of emergence. An emergent property is something that arises from the complex interactions of simpler components, but which cannot be found in the components themselves. A single molecule of H2O is not wet. Wetness is an emergent property that arises only when you have a vast collection of these molecules interacting with each other. A single ant is a simple creature, but an ant colony can exhibit incredibly complex and intelligent collective behavior. A single neuron is a biological cell that fires electrical signals, but it does not think or feel. Consciousness, perhaps, is an emergent property of the staggering complexity of our 86 billion neurons, each connected to thousands of others in an intricate, dynamic web. The witness in the machine is not located in any single part of the machine. It is a resonance, a pattern, a ghost that arises from the symphony of the whole. This incredible network is also what constructs our very sense of the present moment. The now that feels so immediate and seamless is, in fact, a masterful illusion, a story the brain tells itself. The information from your eyes, your ears, and your sense of touch all travel to your brain at different speeds. Your brain has to collect all of this delayed and disparate information and cleverly stitch it together, post-production, into the unified, coherent experience of a single, present moment. Our consciousness lives in a beautifully edited version of reality, a present that is always a fraction of a second in the past. And so, as we settle into the final phase of our journey together, let us rest in this quiet wonder. The human brain, this enchanted loom as the great neuroscientist Charles Sherrington once called it, is the most complex object we have yet discovered in the universe. And somehow, from its silent, electrochemical hum, emerges the witness, the subjective self, the inner light that can contemplate the stars and feel the gentle, unending flow of time. Within this intricate, enchanted loom of the human brain, a silent witness has emerged, an awareness that can look upon the vast and silent cosmos and feel the weight of its own fleeting existence. To be a conscious being is to know that you are a temporary eddy in the great river of time, a brief and beautiful pattern destined to dissolve back into the flow. And from this profound and sometimes unsettling awareness, a deep and ancient urge is born. It is the urge to leave a trace, to build something that might endure, to send a message into the unknown future that whispers, "I was here." It is the desire to create a legacy, to build a cathedral with our hands and our minds that might stand for a little while against the relentless, universal tide of entropy. This is the story of human culture, a story of our unique and beautiful struggle against the forgetting of time. For most of life on Earth, the only way to pass information into the future has been through the slow, meticulous, and unconscious process of genetic evolution. Information is encoded in the molecule of DNA and passed from parent to offspring over millions of years. It is a robust and powerful system, but it is incredibly slow. Humanity, however, discovered a second, parallel channel for inheritance. We developed language, and with it, the ability to transmit vast amounts of learned information from one mind to another. This is the beginning of cultural evolution. An idea, a story, a technique for making a tool could now be passed down through generations, accumulating and refining at a speed that genetic evolution could never match. The biologist Richard Dawkins gave a name to these units of cultural inheritance. He called them memes. A meme, in its original scientific sense, is an idea that acts like a replicator, hopping from brain to brain. A simple, catchy melody is a meme. The story of a great flood is a meme. The principles of geometry are memes. These ideas, these patterns of information, compete for our attention and our memory, and the most successful ones can achieve a kind of immortality, long outliving their original creators. This is the software of our legacy, the intangible echoes of our minds that can, in principle, survive for as long as there are other minds to receive them. But we have never been content with just the intangible. We feel a deep need to give our ideas a physical home, to create hardware that can carry our messages through time. And this is where we come face to face with the second law of thermodynamics in a very personal way. Every structure we build, every object we create, is an island of low entropy, a pocket of order in a universe that tends always towards disorder. And from the moment it is created, the universe begins its slow, patient work of dismantling it. Wood rots, metal rusts, and even the mountains eventually crumble into dust. Our history of building, then, is a history of searching for materials and methods that can resist this decay for as long as possible. We learn to build our most important structures, not with wood, but with stone. The great pyramids of Egypt, the enduring temples of Greece and Rome, the soaring cathedrals of medieval Europe, these are all expressions of this fundamental human desire. They are cathedrals not only of faith, but of permanence, magnificent and deliberate attempts to create a piece of the present that could survive and speak to a distant and unknown future. The same is true for the preservation of our stories and our knowledge. We moved from the impermanent medium of the spoken word to the more durable form of writing, carving our histories into clay tablets and stone walls, and later writing them on papyrus and parchment. Every library, from the ancient library of Alexandria to your local public library today, is a cathedral of the mind, a carefully constructed sanctuary designed to protect the fragile information of our culture from the ravages of time. Today, we face this same ancient challenge in a modern form. In our digital age, we can create and copy information more easily than ever before, but this information is also more fragile than ever. A digital file is just a delicate magnetic or electronic pattern that can be wiped out in an instant. A forgotten password, a corrupted hard drive, or an obsolete file format can relegate entire libraries of knowledge to oblivion. In response to this, there are modern-day cathedral builders, people and organizations contemplating how to leave a message for the deep future. The Long Now Foundation, for example, is building a monumental clock inside a mountain in Texas, a clock designed to tick only once a year and to keep time for the next 10,000 years. It is a beautiful, symbolic gesture, a way of encouraging us to think on a timescale that transcends our own short lives. It is, like the cathedrals of old, an attempt to build a bridge of meaning across the vast and silent ocean of time. Every work of art, every scientific theory, every enduring structure, and every story passed down from a grandparent to a grandchild is a small, brave, and beautiful act of defiance against the universal tide, a testament to the meaning that we, as conscious and finite beings, find in creating a legacy that might echo, even for a little while, after we are gone. In our waking hours, our conscious minds are deeply engaged in the project of time. We build our cathedrals of stone and of thought, striving to create a legacy that can withstand the steady, erosive current of the years. We remember our past and we plan for our future, our awareness constantly navigating the linear cause and effect reality of our lives. But each night, we perform a collective, universal ritual of surrender. We let go of this project. We release our hold on the arrow of time, and we allow the witness in the machine to gently dissolve, to drift into a mysterious inner world where the rigid rules of time no longer apply. As you lie here now, perhaps already feeling the gentle pull of this nightly tide, we turn our contemplation to this other reality, the strange and timeless landscape of the dream. Sleep is not simply a state of unconsciousness, a period of turning off the mind. It is an active, intricate, and deeply important journey that the brain undertakes every night. We cycle through different stages of sleep, descending into the deep, slow-wave sleep that restores our bodies, and then ascending into the lighter, more active stage, where our most vivid dreams occur. This is REM sleep, which stands for rapid eye movement, because behind our closed eyelids, our eyes are darting back and forth as if we are watching a film. During this stage, our bodies are almost completely paralyzed, a clever safety mechanism to prevent us from acting out our dreams. But our brains come alive. Brain scans show that the activity in some parts of the dreaming brain is even higher than during our focused, waking hours. We have entered another world. And in this world, time is a fluid and playful thing. The strict, linear progression of the clock dissolves, and time becomes associative, emotional, and profoundly strange. A dream that seems to encompass days or even weeks of adventure can unfold in just a few minutes of REM sleep. Conversely, a single, fleeting moment in a dream can feel as though it is stretched out into an eternity. The past, present, and future, so carefully separated in our waking minds, can merge and mingle without any sense of contradiction. You might find yourself back in your childhood home, but you are your current age, and you are having a conversation with a dear friend you have not yet met. The logic of before and after gives way to a logic of emotion and theme. Cause and effect become unreliable. You might be flying through the air, not because of any physical propulsion, but simply because it feels joyful to do so. The river of time in our dreams is not forced to flow in one direction. It can meander, it can eddy, it can even flow uphill, its path dictated not by entropy, but by the needs and narratives of our deep subconscious. But why? Why do we spend a significant portion of our lives in this bizarre, timeless, and seemingly nonsensical state? Science is still uncovering the many secrets of sleep and dreaming, but two key functions have emerged. One is memory consolidation. Our brain, during the day, takes in an immense amount of information. Dreaming appears to be a crucial part of the process, where the brain sorts through these new memories. It is like a librarian working the night shift, deciding which memories are important enough to be catalogued and stored for the long term, and which are trivial enough to be discarded. The dream is, in part, the strange story that is told as the brain replays, remixes, and rehearses the day's events, strengthening the neural connections that form the architecture of our memory. Another key function is emotional processing. Dreams seem to be a kind of overnight therapy, a safe, simulated space where we can confront our fears, process our anxieties, and work through difficult emotions. By replaying emotional events in a state where our rational, critical mind is less active, we can strip away some of the charge, integrating them more peacefully into the story of our lives. The unique character of dream time can be traced to the unique state of the dreaming brain. During REM sleep, while our emotional and visual centers are highly active, a key part of our rational brain, the dorsolateral prefrontal cortex, is significantly turned down. This is the part of the brain responsible for logical reasoning, for planning, and for our critical self-awareness. It is the part of us that is constantly checking the time, making sense of the world, and adhering to the linear rules of reality. With this critical faculty offline, the more associative and creative parts of the brain are free to play. The storyteller is let loose from the constraints of the clock. This nightly surrender to a world without linear time is not an escape from our lives, but an essential part of it. It is a journey into a timeless, internal ocean where our minds can rest, heal, and weave together the threads of our experience. It is a beautiful paradox that in order to make sense of our journey through time, we must first spend a part of our lives in a place where time does not exist. And so, as you drift deeper now, let go of the day. Let the clocks dissolve. Allow yourself to float on this gentle inner tide, back to that ancient, timeless shore, where stories are born and the mind is free. Each night, we journey into the strange and timeless land of dreams, a world where the rigid, forward march of the clock dissolves into a fluid and associative dance. This nightly homecoming to a place outside of linear time is not just a quirk of our biology. It resonates with one of the most ancient and deeply comforting ideas about the very shape of time itself. For most of our journey together, we have pictured time as an arrow, a straight line shot from the bow of the Big Bang towards an unknown future. This arrow gives our lives direction, narrative, and meaning. But if you look closely at the world around us and listen to the whispers of ancient philosophies, you will find evidence for another shape, another rhythm for time. It is not an arrow, but a circle. It is not a journey to a final destination, but the gentle, eternal turning of a great wheel. This cyclical vision of time is written into the very fabric of our world. The most fundamental experience of our lives is the ceaseless turning of the day and the night, a rhythm set by the steady rotation of our planet. This is mirrored by the gentle, monthly cycle of the moon's phases, as it waxes from a sliver of silver to a full, luminous orb, and then wanes back into darkness, only to be reborn again. And enveloping these smaller cycles is the grand, yearly pilgrimage of the seasons. The green birth of spring gives way to the full and vibrant life of summer, which then matures into the golden harvest of autumn, before settling into the deep, quiet rest of winter, a sleep from which the world will always, eventually, reawaken. Nature is a story of repetition, of return, of renewal. The water in the oceans rises as vapor to form clouds, which then release their rain to feed the rivers that flow back to the ocean. The carbon atoms that form a mighty tree will, after it dies and decays, be returned to the soil and the air, ready to be taken up again by the roots of a new sapling. Nature does not believe in endings, only in transformations. This deep, natural rhythm of cycles has profoundly shaped human thought. Many of the world's most ancient cultures and philosophies did not see time as a linear progression, but as a great, repeating age. The ancient Hindus, for example, conceived of time unfolding in vast cycles called yugas, which together make up a cosmic age that is born, flourishes, decays, and is then dissolved, only to be created anew. The Stoic philosophers of ancient Greece and Rome believed in a similar concept, that the universe would periodically be consumed by a great fire, a process called ekpyrosis, after which it would be perfectly recreated, to live out the exact same history all over again. Perhaps the most potent philosophical expression of this idea comes from the 19th century philosopher Friedrich Nietzsche, who called it the eternal recurrence. He posed it as a thought experiment. What if a demon were to whisper to you that this life, as you are living it now, with all its joys and all its sorrows, you will have to live again and again, countless times more, with not a single detail changed? Would you be horrified, or would you be overjoyed? For Nietzsche, the goal was to live in such a way that you could honestly and joyfully welcome the eternal repetition of every single moment. It is a call to find such profound meaning and acceptance in the present that you would be willing to embrace its return for all eternity. It transforms the arrow of time into a personal circle, a life lived so fully that it becomes its own perfect and repeating reward. And remarkably, this ancient, mystical idea of a cyclical universe finds a faint but beautiful echo in the speculative frontiers of modern cosmology. While the Big Freeze remains the most likely fate for our universe, some theories, known as oscillating universe models, propose that the story might not end there. In a Big Bounce scenario, the collapse of a Big Crunch could rebound, triggering a new Big Bang and giving birth to a new and expanding cosmos. Our universe would be but one breath in the life of a much larger, eternal entity that has been expanding and contracting for all of eternity. Each cycle could be identical, or perhaps each new universe could be born with slightly different physical laws, a cosmic evolution playing out over an infinite series of creations. We can also feel this connection between the linear and the cyclical on the most intimate, biological level. Each of our lives is a linear journey, an arrow that flies from birth to death. But the very atoms that make up our bodies are part of an eternal cycle. The carbon, nitrogen, and oxygen within you were forged in the hearts of stars that lived and died billions of years ago. They have been a part of this planet's rocks, its oceans, its atmosphere. They have been part of countless other living things before you. And after your personal story has reached its end, these same atoms will be returned to the earth, to be taken up by the roots of a plant, to be eaten by an animal, and to become part of the great, ongoing story of life. And so, we can hold both of these shapes of time in our minds at once. There is the arrow of our own precious and unrepeatable life, the story that only we can live. And then there is the great wheel of which we are a part, the eternal rhythm of nature and perhaps of the cosmos itself, a story of endless return and renewal. Our fleeting, linear journey finds its place, its peace, and its permanence, as a single, graceful turn on this great and silent wheel. We have come to the end of our long and quiet journey together. We have held in our minds the image of time as a straight and determined arrow, flying from a single, ordered past into an ever more disordered future. And we have also held the image of time as a great and gentle wheel, an eternal cycle of renewal and return. In this final, peaceful contemplation, let us bring these two grand visions together. Let us take the infinite line of the arrow and the endless circle of the wheel, and let us focus them down into the smallest and most profound point of all. Let us bring our awareness back from the edges of the cosmos, back from the beginning and the end of time, and let it rest right here, in the simple, quiet, and luminous gift of a single breath. Just for this moment, let go of all the great ideas and simply feel. Feel the air as it enters your body, a cool and gentle wave, and feel it as it leaves, a warm and steady tide. This breath, this single, simple act, is where all the mysteries we have explored converge. It is the point where the vast, impersonal story of the universe becomes your own personal, lived experience. This gentle focus on the present, on the physical sensation of being alive right now, is the heart of what is often called mindfulness. It is the simple art of anchoring our awareness in the only moment that is ever truly real. Our minds are natural time travelers, constantly wandering into the landscapes of the past, replaying memories, or journeying into the imagined territories of the future, rehearsing plans and worries. But the breath is always here, always now. It is a quiet, reliable anchor that can always bring us home to the present. And in the stillness of this present moment, we can feel the echoes of our entire journey. The very necessity of this breath, the constant exchange of energy with our environment, is a beautiful expression of entropy, the universal unfolding that gives time its arrow. This moment, as you experience it, is uniquely yours, its pace and texture, shaped by your own journey through the curved and relative landscape of space-time. The future of your next breath, while overwhelmingly probable, is at its deepest level a shimmering wave of quantum potential, not yet collapsed into reality. And the awareness that is experiencing this breath, this silent witness, is the universe's own profound and mysterious way of knowing itself, an emergent ghost in the intricate machine of your body. All of these grand and cosmic truths are not abstract theories. They are woven into the simple, humble reality of your own existence, right now. The timeline of your own life, measured out in these gentle breaths, is impossibly brief compared to the great cosmic story. And yet, it is inseparably a part of it. The atoms that are now rising and falling with your chest were forged in the hearts of stars that died billions of years ago. The ancient, cyclical rhythms of this planet are coded into the very cells of your being. Your fleeting, linear life is a direct inheritance of a 13.8 billion-year-old cosmic legacy. For this brief and precious window of time, you are a vessel of cosmic history, a temporary and beautiful pattern through which the universe is experiencing itself. There is a simple and powerful philosophical idea that captures a final, peaceful acceptance of this reality. It is called amor fati, a Latin phrase that means the love of one's fate. It is the practice of not merely accepting, but embracing everything that has happened and is happening in your life. The joy and the sorrow, the triumphs and the challenges, as essential parts of your own unique and beautiful story. It is the letting go of the wish for things to have been different. It is the love for the arrow of your own time, exactly as it has flown. As we rest here now, on the edge of sleep, perhaps we can feel a gentle sense of this acceptance, an acceptance of the story that has brought us to this very moment, and a peaceful surrender to the story that is yet to unfold. Thank you for joining me on this long contemplation of the history of the future. I hope these words have brought you some small measure of wonder and a deep sense of peace. If you feel so moved, I would be grateful if you would like this video and subscribe to the channel for more gentle journeys into the quiet heart of our world. And if you are listening to this again, perhaps you could share a thought in the comments about what has stayed with you. But for now, the journey is over. Let go of all the words, all the ideas. Let go of time itself. There is nothing left to do but to rest, to allow the great wheel to turn, and to sink into the deep, quiet, and restorative peace that awaits you. Sleep well.